Hey guys, how's everyone doing? Welcome to the first day of our online classes, our first actual day where we're actually doing something. Today we're just going to start off and we're going to go back to, I guess, Unit 4, and we're just going to kind of go from the beginning of that one. We're just going to talk about today sine functions, and we're just going to go over their properties. That's all we're going to do today. So, to start us off with, we have properties of sine functions, okay? And that generally is going to look like y is equal to sine x. Now, for y is equal to sine x, when you were to graph this function, it's going to start out at 0, and it's going to look like a wave. So from 0, it's going to go to pi over 2, okay? And it's going to go to 1. And when it goes to pi, it's going to come back down to 0, or come back down to 0. When it goes to 3 pi over 2, it's going to go to negative 1. And when it goes to pi, or 2 pi, I'm sorry, it's going to go back to 0. So it should look something like this. Okay? And it'll go on this to infinity. So as it comes to this other side, it's going to repeat this same scenario. Okay, when it's going down, it'll peak at negative 1, then it'll go back up and peak at 1. So at negative pi over 2, since we're going down, it's going to go to negative 1. Since now we hit 1, or negative 1, it's going to go back up. So at negative pi, it's 0. At negative 3 pi over 2, it's going up. So it hits 1. And then it peaked, so now it goes back down to 0. So it should look something like that. And this will go on to infinity. Okay? So now when we talk about domain and range, okay, we're going to talk about domain. So the domain for this, since this does this onto infinity and there's no spaces along it, our domain is going to simply be, sorry, let me fix this for you. Negative infinity to infinity. Okay? And we're only talking about range value, or sorry, we're talking about x values. So as it goes to the right and goes to the left, it'll keep going on to the left, so that's negative infinity, and it'll keep going on to the right, so that's infinity. So we have our x coordinate and y. So next we'll talk about range. Range are up and down, okay? Y-axis. So for this one, we have a minimum value of negative 1 and a maximum value of 1. Doesn't matter if it repeats or not, that's what we have. So for this one, we'll have negative 1 and 1. Now, remember, for domain, since we go to infinity and negative infinity, we're not going to include those numbers because infinity is arbitrary. We really don't know. We can't count to infinity, but you can count to 1 and negative 1. So we have to make sure we use brackets on those and include them. The next property we talk about is the y-intercept. Y-intercept is when it crosses the y-axis. Okay, so when it crosses the y-axis, it's actually going to be right here at 0. So we're just going to put 0. That's the only one. It never crosses it here or here, so that's the only one we have. So the next one we talk about is x-intercept. So for the x-intercept, it crosses the x-axis at 2 pi, pi, 0, negative pi, negative 2 pi, and that actually goes on to infinity. It's going to keep heading that thing forever. So what we will say for that one is n pi, where n is a whole number. What that's essentially saying is n can be 0, 1, 2, 3, 4, 5, 6, going on to infinity, and n can also be negative 1, negative 2, negative 3. So if you were to plug one of those values in, it would account for 0, pi, 2 pi, and so forth. It would account for everything essentially. All those values it would account for. The next one we're going to talk about is continuity. Is it continuous or is it non-continuous? Since this is going to be a little wave, it's just going to do this on for forever, okay? There's no gaps, there's no missing pieces to it. It is considered continuous. So we're just going to say continuous on negative infinity to infinity. Now symmetry. Remember, for symmetry, we're looking for it to mirror. If I was to take this and fold it over, okay, that wouldn't be symmetrical, so it doesn't have y-axis symmetry. If I were to take it and fold it this way, this doesn't have anything over here, so it can't be x-axis symmetry. Now it does have one form of symmetry, and that's about the origin. If we were to take this function right here and rotate it by 180 degrees, it would just be a mirror image of itself. So for this one, we're going to say its symmetry is about its origin, and that makes it an odd function. Okay. The next one we're going to talk about are extrema. So for extrema, we're talking about max or mins. So for this type of sine function, we do have maxes and mins. We have a max. We have a max right here, and we have a min right here. So we're going to say a max of 1 at x is equal to pi over 2, right? So pi over 2 we have right here. We have to account for every value. So not just here, but we also have one here. So we'll have x is equal to pi over 2 plus 2 in pi. So that's saying if I was to take this value right here and I'm going to subtract 2 pi, it would give me this value right here if I add 2 pi. So it's going to be kind of that. So that we'll also have this little function on the outside that says, or I guess this little statement where it says n is a whole number. That's just allowing us to find other values as well with it. Oh, not max. So then we'll go for the next one. Now this one's a minimum. So we'll have a minimum of -1 at x is equal to 3 pi over 2 plus 2n pi. Same thing. If we were going to count over here, we would have a value of negative pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi. So that's our values. So we have where n is a whole number once again. And that's the majority of the things we'll do for this one. And the last thing we're going to talk about is in behavior. So in behavior for us, sorry, I hope that didn't split on y'all, is what's happening as this thing goes to infinity and negative infinity. Okay, so what we kind of say for this one is the limit exists. Is there some number it approaches? For us, it doesn't approach anything. So we say the limit as x approaches negative infinity. So as x goes to negative infinity, is there a value it approaches? So limit of sine x. Okay, and that does not exist. It doesn't approach any values because this is just going to keep oscillating. It's going to keep going up and down. It doesn't actually go to one point, or it doesn't head off in one direction and go to infinity. Then we do the next side. The limit as x approaches the limit, and I just put an IET. You can put LIM. That's how you do limit. As x approaches infinity of sine x. Okay. Once again, as it goes to the right, it just keeps oscillating. It keeps going up and down. It doesn't approach a number, or it doesn't go to infinity or negative infinity. So once again, it is no solution. It doesn't exist. So there is no in behavior for these. There's no limit. That's all I was going to talk about for this one. I know the video is a little long, okay, for properties. It takes a little bit because I got to go through them all. That's why today, just watch the video. I just want y'all to be able to watch it, know what's going on, and that's it. We'll have our daily ticket that goes with this, but that's about it. Okay, hope you'll have a great day, and I'll see y'all. I hope I'll see y'all soon. Okay, bye.